Have you ever known someone who just didn't feel right after a concussion, even when all their tests came back totally normal? It's a really common and honestly a super frustrating story. So today, we're going to dive into the science that's finally starting to make this invisible injury, well, visible.
In this slide, this really gets to the heart of the mystery with mild traumatic brain injury, or mTBI. On one side, you have patients telling you about these very real, very disruptive symptoms: brain fog, memory issues, feeling slow. But then on the other side, the standard tests they're given often come back showing that, hey, everything's fine. And that creates this huge, frustrating gap between what someone is feeling and what a doctor can actually measure.
And we're not talking about a small number of people here. For a pretty big chunk of them, these problems don't just magically disappear after a few days. Research shows that at least 15% of people who get a mild traumatic brain injury end up dealing with these persistent cognitive issues long after that initial hit.
And these aren't just minor annoyances, They can seriously mess with your day-to-day life. We're talking about real trouble concentrating at your job or in class, struggling to remember new things, and just that general awful feeling that your brain is running in slow motion.
So this exact clinical puzzle is what a team of researchers decided to tackle. You can kind of think of them as detectives, right? They're on the hunt for clues to figure out what all the standard medical tools were missing.
They started with the most fundamental question of all. If all the usual tests are coming back clear, where is the problem? Is it all in the patient's head? Or, and this is the key, could it be that the tools we're using just aren't sharp enough to see the subtle damage that's really there?
The researchers had a hunch. They hypothesized that the dysfunction was absolutely real. It was just hidden. They knew they needed a whole new approach, a much more sensitive tool that could look right past behavior and measure brain function directly as it was happening.
And that brings us to their method, how they actually did it. To find these hidden clues, they picked a technique that basically lets them listen in on the brain's electrical chatter while it's trying to work.
It's called event-related potential, or ERP for short. And what it is this amazing, non-invasive way to measure the brain's tiny electrical zaps in response to a specific thought or a picture they see. What makes it so incredibly powerful is its precision. We're talking it can track what your brain is doing down to the millisecond.
So to really stress test the brain, they gave participants a working memory challenge. Okay, here's how it worked. First, you had to memorize a set of 4 kind of weird, abstract images. Then, after a short pause, a 5th picture would pop up, and you had to decide, was that new image part of the original set you just saw? It's a task specifically designed to push the brain's memory and monitoring functions.
The experiment had 2 groups. You had 44 patients who had a history of mild traumatic brain injury. And then, for comparison, you had a control group of 40 healthy volunteers who were matched for age and sex and had no history of brain injury. This comparison is absolutely crucial to see the differences.
All right, so the stage is set. After all that, what did listening to these brainwaves actually show? This, my friends, is where the story gets really, really interesting.
So first, let's just look at how well they did on the test itself. The mTBI group, they got it right about 83% of the time. The control group was a bit better, almost at 89%. Now that's a real difference for sure, but it's subtle enough that it might get overlooked in a regular checkup.
But this right here is the smoking gun. This chart shows it all. When the researchers looked at a specific brainwave, it's called the P300, and it's linked to things like attention and memory, they saw a huge difference. The signal in the mTBI group was just quieter. It was significantly smaller than in the healthy control group.
So to kind of sum up what their fancy equipment found, these key brain signals had smaller amplitudes, less oomph in the mTBI patients. But, and this is super important, there was no difference in the timing of the signals. So what that means is the brain's response wasn't slower, it was just weaker.
And here's how it all clicks together. The researchers found a direct correlation. Those smaller, weaker brainwaves were directly linked to the slower reaction times and the lower accuracy on the memory test. For the very first time, they had a clear physical explanation for those cognitive problems people were reporting.
So what's the final verdict here? What does this all mean for patients, for athletes trying to get back on the field, and for the doctors who are trying to help them? The most powerful takeaway is this: a patient's symptoms are not just in their head. These quieter brainwaves are objective, measurable proof of real underlying dysfunction in the brain, the kind of thing that standard clinical tests just flat out miss.
The authors of the study put it really bluntly.
They say that doctors and clinicians need to wake up and realize that even after a so-called mild injury, patients likely have these persistent brain dysfunctions that absolutely have to be taken seriously and looked at more closely.
So why is this such a big deal? Well, a few reasons. First, it tells us that our standard 7 to 10 day recovery window for a concussion, probably way too optimistic. Second, those huge decisions, when can an athlete return to play or when can you go back to work, they need to be based on better, more objective data like this. And maybe most importantly, it finally validates what patients have been saying all along. I'm not making this up, my symptoms are real.
And this leaves us with a really critical question for the future. If an injury that we call mild can leave such a clear and lasting fingerprint on how the brain functions, it really forces us to stop and ask, how do we need to completely redefine what recovery even means?